We cannot find in the Unix reference manuals everything we need to know in order to use Unix command effectively and efficiently. Some things are good practices established through convention or learned through trial and error that are passed among experienced users. This is the topic of the current unit. We'll go over the practices as things to do and avoid. We must send error messages to the standard error channel, not the standard output.
To do that, we redirect the command's output to &2. Number 2 represents the standard error stream. Here, I run echo error and redirect it to &2. This outputs error, but on the standard error, which also corresponds to my terminal. Notice that if I repeat the same command and redirect the standard output to a file, we would normally expect to get no output on the screen. However, error still appears on the screen because the standard error has not been redirected.
We must explicitly specify a directory when we want to move files into it by suffixing the directory name with a slash.
Let's see an example. First, I create a file A and a directory. Then, I move file A into directory. Notice here that I've misspelled directory as directory. As a consequence, listing the current directory's contents, we see that file A was renamed to directory instead of being moved into directory. Let's restore the file by renaming directory back to A. Now, I move again file A into the misspelled directory, but this time I use a safer syntax by appending a trailing slash to the directory's end. As we can see, this outputs an error message, preventing the file's renaming. Finally, let's move A into the properly spelled directory. Listing the current directory, we verify that the directory exists here. Also, looking at the directory's contents, we see that the file A was successfully moved.
We must clean up our temporary files when we finish executing a script.
Let's see how we can do this in a Unix shell script. First of all, I create a variable named tmpdir to contain my temporary files directory. If the environment variable tmp is not already set to a different user-specified directory, tmpdir will be /tmp, followed by the current process identifier, so that it will be unique among all running processes. Next, I specify two trap commands, a general one to handle the program's termination and a special one for its potential interruption. Trap allows us to catch signals and execute code when they occur. In this case, when the program terminates, trap recursively removes the temporary directory. In addition, if the program's termination is caused by a signal's interruption, such as a user's Ctrl+C, I specify to exit with an exit code of 2. Then, this is trapped by the above command, which again removes the temporary directory. Finally, I create the temporary directory. From there on, I can operate on it as I like by storing files and so on, being sure that it will not be left behind no matter how my script terminates its operation.
Some systems feature common file paths with embedded spaces, such as program files or my documents. This can confuse how the Unix shell passes arguments to commands because it traditionally uses white space to separate command line arguments. Here are some examples of how this happens and how we can avoid it.
On a Windows system, there are two options to list and count the number of files in program files. First, we can enclose the name within single quotes. Alternatively, we can escape the space with a backslash. This translates into program \space files. Let's store the name program files in a variable. Running ls on it fails because the variable is expanded and passed as two words to ls. To prevent this, we enclose variables within double quotes, which allows them to expand as a single word.
Some tools, such as xargs, find, and grep, have special options in order to deal with file paths with embedded spaces. When these commands accept or produce file paths, instead of using space or newline as a file path separator, they use a null byte, which cannot legally occur within a file path.
Let's see some good practices. In the find command, we can specify the -print0 argument as we've seen in the past. This separates the output files using a null character instead of a new line based on the fact that there are no nulls in file names. Next, I pipe the output to xargs with a -0 option to specify the same convention. The input is specified by null characters rather than new lines or spaces. In this way, I can run grep on the complete file names even if they include spaces. Notice another trick here. I also specify devnull as an argument to grep. Why do I do that? In case find doesn't output any file, then xargs will still invoke grep. Grep in turn won't receive any argument and will expect its input from its standard input. This will cause the script to stop waiting for input. By specifying an empty file as an argument to grep, in this case devnull, we ensure that grep's input will always be a file rather than the standard input. Alternatively, we can pipe find's output to xargs -r-0. Here, -r ensures that xargs will only execute the command if at least one argument is passed to it. A similar problem occurs when grep lists file names which contain spaces. In this case, some grep versions include a -z option. This separates output file names with a null character similar to the find command. Then we can pipe the output to xargs. Here I remove all files matching the specified pattern. To handle spaces in file names, we can also null separate newline terminated file lists on our own. Consider the case where we want to mirror a directory hierarchy without its files. For example, I want to mirror the directory under vol A into vol B. After obtaining the vol A directories, I pipe them to the set command to rename their parent directory from A to B. Next, I need to pipe the output to the makedir command in order to recreate the directory hierarchy under B. However, if these directories contain spaces, then there is a problem because makedir will see them as separate arguments. To resolve it, I first pipe the output to the tr command, replacing all new lines with null characters. Finally, I run xargs -0 makedir to create the directory hierarchy under vol B. The vol B names are now separated with a null character rather than a new line.
When running the test command on files, we must consider the possibility that the file path might be empty or start with a dash character. In both cases, this can cause test to either miss the argument or mistake it for a command line option. This is a problem with many other commands as well.
To guard against both possibilities, we can prefix the variable we want to expand with an x and put it inside double quotes. Therefore, even if the variable's value starts with a dash, x will precede the dash and the dash won't be misinterpreted by the test command. In case the variable's value is empty or contains spaces, the quotes around the variable and x ensure that exactly one value will be used on the left-hand side of equals.
You may consider all this advice arbitrary or difficult to remember. Don't despair. By running the shell check tool, your scripts you can catch diverse mistakes or inadvisable practices. Here is an example of possible problems that shell check can identify.
Let's create a Unix shell script with a here document. It only includes one command, which intentionally contains some problematic constructs. What does this command do? It attempts to catenate the current directory's contents, count the total characters through word count, and then echo the result. Now, let's run shell check on this script. As expected, we get some warnings for line 2 where the command is. Each warning is associated with an error code which we can search on the GitHub wiki page of shellcheck. The first warning informs us that we should quote the echo's argument to prevent unintentional word splitting. The second warning identifies the redundant use of echo and advises us to remove it. If we wrongly decided to keep echo, shellcheck suggests replacing the legacy backticks with a $sign followed by brackets, which, in contrast to backticks, can be nested. Finally, cat's wildcard argument could pass to cat a name starting with dash, which cat could treat as an option. To prevent this, we can prefix the wildcard with ./ or pass the files after the --" option, which by convention for many commands terminates the option parsing.
This concludes our professionalism unit on good shell practices. Stay with us.